Shake Table Lab by Hannah Bogen and Libby Garrett. Every group started like this. We are sketching our design for the structure. To begin constructing our building, we made the base and the sides of the first story. To add support to our first story, we created cross braces on each of the sides. Then we started constructing the second story of our building. We then produced cross braces for the second story, which created even more support for our building. Lastly, we laid out the cross brace and the paper floors that the sandbags would later be tied onto. Then we taped on the string. The first story of our building was 18 square centimeters, and the second story of our building was 19.5 centimeters. The base of our building was 18 square centimeters. To test our building, we put 5 sandbags on our building, 2 on the bottom and 3 on the top story. This way we could see if our building would be able to withstand the weight of the sandbags without shaking. To strengthen our building, we put straws that we had left on the sides of the building to help the floors where the sandbags would eventually lay. We also made cross braces to make the building more stable and to make the building less susceptible to earthquake damage. The strongest part of our building was the sides where we put the extra straws to help support the first story. One other very strong part was the places where we put cross braces, because the cross braces help support the building and make it more resistant to earthquake damage. The weakest parts of our building was the diamond shape in the picture. When we put too much pressure or too much weight on the building, the diamond shape starts to collapse, which makes the building weaker. We used the string to tie in the sandbags for the testing, and then we decided it was a good idea to put the string there for the final test as well. The tape was very useful for keeping things together, such as straws, the paper, and keeping the building on the base. We used the tape a lot at the corner of our building and at the cross braces for extra support. We would put straws in that triangle because that is one of our weakest parts. If we had 5 more straws, we could have easily been able to do this because that space had not been even 1 straw long.
Go. That's major. Uh-oh.
Wow.
The straw's cricket.
You're like, we.
Yay! It's your
The picture at the top shows the sensor readings from when our building failed. Our final sandbag score was 2 sandbags on the top story and 3 sandbags on the bottom story. The blue lines represent the movement on how much our building moved at the top. The green was the forward and backward movement that our building made, and the yellow was the side-to-side movement that our building made.
Hi, I'm Libby Garrett, and I'm here to talk about our Shake Table Lab. Our building supported 2 sandbags on the top story and 2 sandbags on the bottom story. I was very proud of it. It was really great. Our building failed on the sides and on the bottom. So on the sides, it would collapse because it would of the pressure and of the weight, and on the sides, it would rock back and forth, and it would just rock because we didn't put enough tape on it. If I was to build it over again, I would probably, I don't know, I would have had a really fun time with it, but I'd probably add more cross braces on the sides and more tape on the bottom because you don't want that to rock because that would be really scary and bad. I learned that it's very hard to breaking is easy, but making is very hard, a earthquake proof, what is it called, building, because you have to have a lot of materials and it has to like all be cohesive and it has to like all work together instead of like individual pieces that you put together. And yeah, I like this project because you could have different designs and you could always have like and there was many different designs and it was really cool to see all of them work and how they would fail and stuff. And so also I thought it was really cool how you could like we did different designs and oh, I already said that. Okay, and also
Hi, I'm Hannah Bogen, and today I'm going to be talking about our Shake Table Lab. In this lab, we had to build an earthquake-proof building with only straws and tape. The building had to fit on a 25 by 25 centimeter cardboard base. Our building supported 2 sandbags on the top story and 2 sandbags on the bottom story. Our building failed because the corners of our building were not locked down enough to the cardboard base. So, when we started shaking it, the building rocked, which created more stress to our building. So, because of this, all of the corners of the building pushed out at once and our building collapsed. If I was to build my building over again, I would put more vertical cross braces and some horizontal cross braces. I learned about building earthquake-proof buildings. I learned that lock down to the base enough that they won't rock. Well, and anyway, in a real life earthquake, that would be really scary. I also learned that you need to have a lot of cross braces, and you don't only need to have the X cross braces, but you also need to have horizontal and vertical. What I liked about this lab was that you could really have an open mind about it. There wasn't a set design that you had to follow. You could really be creative. Thank you.